Let us deal with the first problem. In a photoelectric experiment setup, photons of energy 5 electron volt falls on the cathode having work function 3 electron volt. So over here I can write that the incident energy is equal to 5 electron volt and the work function phi is equal to 3 electron volt. So if we calculate the value of the maximum kinetic energy of the emitted photoelectrons, so I can say that maximum kinetic energy is equal to incident energy minus work function phi. So if we do this, so we can obtain that the maximum kinetic energy of the photoelectrons emitted is equal to 5 minus 3, that is equal to 2 electron volt. So from here we can also calculate the value of stopping potential. So the value of stopping potential is going to be 2 volt. So from here the question, if we read the first one, so if the saturation current is 4 microampere for intensity 10 to the power minus 5 watt per meter square, then plot a graph between anode potential and current. And B part is asking, also draw a graph for the intensity of incident radiation 2 into 10 to the power minus 5 watt per meter square. So now if we look for this particular graph, so we can draw the graph like this. So on the y-axis we are measuring the value of current, and along x-axis is the value of potential V. So over here the stopping potential is marked as 2 volt. Now if we look at the graphical approach, so if we draw the graph for the first one, that is 10 to the power minus 5 watt per meter square, so the graph is going to be something like this, and the value of saturation current is obtained at 4 microampere and the intensity is 10 to the power minus 5 watt per meter square. Now in the second one the radiation is 2 into 10 to the power minus 5. So as the radiation or the incident radiation is doubled, the value of saturation current will also get doubled. So this time the value of saturation current will be obtained at 8 microampere. Care must be taken that the stopping potential is going to remain the same. On increasing the intensity of the incident light, the number of photoelectrons emitted increases in case of photoelectric effect setup, but the value of the maximum kinetic energy of the emitted photoelectrons remains the same, and hence we say that the stopping potential remains unaffected, but the saturation current will rise, or I can say it will get doubled by doubling the value of incident radiation, which is equal to 2 into 10 to the power minus 5 watt per meter square. So this is the graphical variation of I versus V for the question which is it is asking for.